morning, everyone. How are you all doing today? Well, I hope. It's supposed to be a really hot one today, so I'm glad I'm in the basement right now. So, did everybody see the announcement? Yeah. So, I did say that I would not be performing any adjustments on the grade for the midterm, and I'm going to stick to that. But it seems to me that, given how it went for most of you, a second chance to sort of redeem your grade is something that probably a certain number of you would appreciate. So we're introducing a split grade scheme, right? One grade scheme will be the grade scheme as described in the course outline, where it's 30, 30, 40, assignments, tests, and midterm. And the alternative grade scheme will be 30, 15, 55. So half the value of the midterm will be taken and applied to the exam. Whichever of those two grade schemes you achieve a higher grade according to, that will be your final grade for the class. So, if you study really hard and you address the knowledge deficits that will have been revealed to you by the midterm, then you have a chance of recouping some of the loss. It's kind of like, without some kind of scheme like this, that portion of the class which is left would, a fair number of you would have very, very little chance of achieving a B in this class, which is what's necessary in order to be able to continue on taking computer science courses, at least without retaking the course. So that's what we're going to do. You guys have a chance to hold the grade up. I'm not making the exam any easier than it was going to be, so you will have to know the material. I'm not giving out freebies, but your situation is not completely hopeless, so that might be a good thing. So, anyway, we should continue on with the lecture material that we have for today. We're not going to require the entire 3-hour duration to cover the dozen or so slides remaining in this topic. So once we're finished with object-oriented programming, we will continue on to our next topic, which is file I/O, which is a fun one. Also sometimes called permanent memory interaction, but we can talk about that when we get there. Microphone. I really should remember to use the microphone. I was listening back to some of the video from yesterday, and it's like, man, everything is at max volume, and that's too low. Maybe I'll try boosting the signal a little bit when I re-render the video. Test. Is this any better? That's better? Good. Excellent. So, when last we spoke, we were going through the birthday calendar example. We had done up a implementation of this algorithm of our own, and we had basically just implemented and had not quite gotten to the point of testing it. This is our implementation. So let's quickly review what the heck we're actually talking about here, right? So the birthday calendar class is a wrapper for a data structure keeping track of the birthdays that particular people have. During our implementation of this class, we decided to make the keys of this class the birthday dates and the names to be the values inside of a dictionary. In fact, it became necessary, since it is certainly possible for more than one person to have the same birthday, that we have a dictionary whose values are not just simply the strings representing the names, but a list of strings which may represent multiple names. Or, no, now that I think of it, we used sets, didn't we? Yeah. So each entry in the dictionary points to a set containing the names of all of the people who have a birthday on that particular date. So in addition to this overall structure, we were required to add the following methods or actions to this class. Number one, a method which clears the data existing inside of the class. Hello? Hello? Okay. I thought I cut out there for a second. Number two, a method which adds a name and date to the class, or to the object, because at that point it will be an object. A test to see whether or not the birthday calendar contains a particular name as specified, and a test to see if a particular, a method which returns all of the names of all the people who have a birthday on a particular day. So far as it goes. The following is the implementation that we came up with. For our constructor, all that was required was the initialization of an empty dictionary. Clear invokes the constructor, thus overwriting whatever is contained in self.d with another empty dictionary. So it wipes out any existing data that might be there. The add function must test to see if a particular date is already in the dictionary. If it's in the dictionary, what you want to do is you want to add the name that we are currently trying to add to the set currently residing at that entry. And of course, to add an element to a set, one method of doing that is to create a set containing only the item you want to add, and using union, the union operator from earlier in the course, and set theory, if you're more familiar with that set theory in general. If the date is not in the dictionary, we add it to the dictionary. We remember that with dictionaries, you can add a new entry to a dictionary just by assigning something to an unused key. So that's what we're doing here. And we are creating a set that contains only the name that is being referenced here, or that is being provided there. So far, so good? So far, so review? We also have the birthdays and contains method. Because we decided to make the keys of this dictionary the dates, this made the birthdays method extraordinarily simple. Since we are already sorting, or we're already categorizing people by their birthdays, literally all that we need to do to return the set of names is to look up the set corresponding to that date in the dictionary. Now, this may raise a question in your mind. What happens if the date that we're looking for does not exist in the dictionary? Perhaps we want to return a null value, perhaps we want to return an empty set. There could be a number of valid interpretations since it isn't specified in the question in this particular instance. So let's just do something that makes sense, right? If we want to return a set containing all of the names that have a birthday on a particular date, then how about we just shut off notifications? Thank you. What was I saying? Yes. So if this algorithm is expected to return a set, right, that contains all of the names, if a particular date is not in the calendar, then there are no names which are associated with it, obviously. So I would say a perfectly valid interpretation of this is to return an empty set, since no names were found, right? Now, there are two ways of going about this. One, in the initializer, you could just initialize an entry for every single date that's possible and assign that an empty set. That's one way of going about it. A bit memory intensive, but perfectly valid. That way, this guy would not have to change. The other thing you could do is test to see if that date exists in the dictionary, and if it does not, return an empty set. So let's do it that way. If date not in self.d, return an empty set. Remember that empty curly braces has been reserved for empty dictionaries. Empty sets are written thus. There we go. And otherwise, we return the other. So, quick question. Is the else case necessary? Or have I just provided it for the purposes of visual flavor? Yes?
Like if you just put the return statement out of the include, like it'll work anyways?
Yes, it'll work anyways. So, if we were to write this as such, there we go. Remember that when execution hits a return statement, the execution of that function is terminated immediately. The function exits immediately. So, if this condition is met, then a return statement is activated, thus terminating this function. So, if this guy activates, this statement will never be reached, because this one will quit the function before this one is reached, right? So, in a very, technically speaking, putting this guy inside of an else case is unnecessary. The else case will activate only if this one does not. But because this one, if it activates, terminates the function immediately, if it doesn't activate, then it doesn't terminate the function immediately, so anything that continues on from that point is effectively like an else case, right? But, I think it looks a little bit nicer if you put the else case in there. If for no other reason than readability. So, writing the function in this manner does not rely on a human being knowing that about return statements and if statements, right? This is more clearly legible to a human being. It's like, if this, else that. Despite what the, what would actually happen in terms of like the underlying code. So, it's up to you which one of those you want to use, but in general, I would lean towards readability and reliability, especially at the beginner level. So far as it goes. So let's talk about the contains method. The contains method's purpose is to pull everything in the dictionary to see if a particular person is represented inside of it. In order to do so, essentially, we have to go through every entry in the dictionary, checking the sets which are pointed to by these entries, and seeing if the name we're looking for resides in any of those sets. This is fairly straightforward. This is a fairly straightforward application of a for loop. For date in self.d, remember that for looping over a dictionary gives you the keys as the loop variable, not the values. If name is in self.d at date, we return true. If we get through this entire loop without having at any point returned true, we return false instead because the name was not found. Does that make sense? Good. So, let's see if this actually works, shall we? So, first we initialize a calendar object. Cal is equal to bday. Cal.add. Nick. There we go. Cal.add. Add two people to the dictionary. There we go. So, we are adding Nick to the dictionary. We are adding Felix to the dictionary. We check to see if it contains George. We check to see if it contains Felix. This is a negative test case and a positive test case. This one should fail. This one should succeed. And then we print all of the birthdays that are contained on a certain date. In this particular case, that should just be Felix. And we also should have a negative test case there as well. That is to say, we're testing for birthdays on an unused date. Unless we test to see if we can see the birthdays on an unused birthday, we are not exercising this branch of the algorithm. So, if you recall from our testing material, good tests test all branches, right? So we need to do that. So, let's say 5/5/1905. Good. So, Python 3, topic 8.py. Boom. And we have an syntax error. Line 46. Yeah, Yeah, it's missing a plus sign. Init missing one positional argument. Oh my god. I'm having errors with stuff that we aren't even talking about. Comment, 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 comment. There we go. So, test case number 1. We were expecting false. We received false. We were expecting true. We received true. We were expecting a set containing only the name Felix. We receive a set containing only the name Felix. We are expecting an empty set. We receive an empty set. Therefore, insofar as we have tested, insofar as these test cases go, this is correct, this algorithm. Of course, there are lots of things that we're not testing here. We're not testing the use of unexpected data types, for example. The fact of the matter is, because this is in Python, date could be, either date or name could be any data type, actually. Like, we could have numbers instead of names and floating points instead of dates, and this would mostly still work. Except, of course, for the fact that testing for a particular date requires a test of equality, which, as we've demonstrated multiple times, floating point should not have equality performed over it. But nevertheless, because Python is so loose with its types, this can be used in very unexpected ways, right? So you're kind of trusting the programmer to use it correctly. Anyway, so that's the birthday calendar. Here is the implementation of the birthday calendar as given in the slide deck. So you can see we have the same solution for an init. We have a slightly different solution for clear. I think mine's better. Adding an entry to the dictionary. So they've chosen a different way to implement this than we chose, right? Basically, they've got their dictionary flipped around the other way. Question?
You said a question with the earlier code.
Yep.
Is cal itself a dictionary?
No, it's an object. It contains a dictionary, right? But if you wanted to, for example, directly try to access the D dictionary contained within cal by referencing cal's name, then you would end up causing problems. So you can't go, for example, cal at, 01/04/2021. Despite the fact that that is a valid key in the dictionary contained within the object, right? If you try to execute that, type error, bday object is not subscriptable. Now, it's possible to overwrite a magic method to make that work, but it's not provided by default, right? Yeah, it's although this object does contain a single dictionary and that's all that it contains, it is not identical with the dictionary that it contains, right? It's not, another way to put that, I guess, would be that we have not chosen to have our birthday calendar inherit from dictionaries, right? So it does not have all of the, it doesn't have all of the operations that you can use on dictionaries available at the surface level. Now, if you went one step deeper into it and accessed the dictionary which is contained inside of it using dot syntax, then everything works, right? But this is a very important distinction, right? This is accessing the contained attribute by means of dot syntax. It is not the same thing as trying to apply something directly to the object itself, right? Like, think about it this way. An object could contain as many dictionaries as you want, right? Let's consider an object that contains 4 dictionaries. If an object contains 4 dictionaries, which of those dictionaries would be accessed if just, accessing it directly from the object worked, right? You'd be asking the computer to select one of those 4 dictionaries as being the dictionary that you access by default using the indexing operation. It doesn't, the computer basically doesn't feel comfortable making that decision for you, right? So what, basically in order to have that available to you, you would have to specify that in some manner. And the way that you do that in Python is overwriting some magic method which defines this operation over that set, right? You'd have to make the indexing operation polymorphic, extend the polymorphism to the newly created object. Does that make sense? Good. Oh, there was something related I wanted to say that now fled from my brain like cockroaches fleeing the light. Iterable. So I just want to briefly mention as well. So the thing that makes for loops work for particular objects is that these objects have a definition for the iterable method, right? Which is another one of these magic methods. Lists, dictionaries, sets, tuples, strings, all of them have a definite definition for iterable. You yourself can also provide a definition for iterable for a custom class that you write. This would allow your class to be interpretable by for loops. And since for loops are very useful, that might be a useful thing to do. Particularly when you have, such a dead simple class like this that only contains the one data structure, it would make sense in some, to some degree it would make sense to extend, to extend this class with those types of definitions. But we're just gonna kind of not do that and move on to the next example. It's possible though. Any other questions? That was a good question. Yes?
It says type error dictionary object is not callable when I try to do the last command.
This one?
Yeah.
Are you using square braces? Yeah. When you get an error telling you that it's not callable, basically if you use round braces here, it thinks that you're trying to call it like a function and providing it an argument. But you're not, you're trying to do the indexing operation. So it's a different operation, basically you used the wrong operation. That's what it's telling you. Any other questions? Yes. It's very important in programming to be able to keep your braces, keep your different types of braces straight. Except for curly ones, which are supposed to be curly, and round ones, which are supposed to be round. So really the only straight braces are the square braces, but again, terrible dad humor. So anyway, in the implementation here, we have an alternative approach to the internal structure of the dictionary. Whereas we decided to make the keys the dates, here they've decided to make the names the dates. Now, one might argue that our way of doing things is slightly more memory efficient, but, you know, it is what it is. So, insofar as our birthday method was very simple, and our contains method was more complicated, the reverse is the case here, because, you know, since the dictionary is storing, is indexed by names, in order to see if a name is in the dictionary, all we have to do is perform the in search over the keys of the dictionary, which is actually by default what you search when you just search X in dictionary. So this becomes a one-liner, which is, you know, reasonably convenient. On the other hand, finding the birthdays is slightly more complicated. So in order to return the set of names which have a particular birthday, what we have to do is initialize an empty set, loop through all of the entries in the dictionary. If the if any particular entry in the dictionary points to a date which is the same as the date specified as an input here, then we add that name to the set. Once all of that is finished, we return the set, and that will be the set of people who have birthdays on a particular day. So it's very similar to our contains method, just sort of going in the opposite direction, if that makes sense. And of course, the slides provide a string conversion method, which is not asked for in the question. And I must state very plainly that if you are performing an assignment, nothing that's not requested or required by the question is worth any marks, so you don't have to worry about adding a bunch of extra bits. Just answer the question. So, very good. Any questions about the dictionary calendar before we move on to the mean calculator? Okie dokie. So, and now for something completely different, although related. Our next task is to design a calculator which calculates the arithmetic mean of a sequence of numbers. We need two operations in this class. We need the ability to add a number n to the set of numbers we are calculating the mean of, and we need a method which returns the mean of the collection of numbers. The mean should account for the same number being added multiple times, exactly as one might expect. Relatively simple. So, here's a question. From a design standpoint, how might we go about storing these numbers? In a list? Sure, let's try it. So, class, mean calc. We won't inherit from anything in this particular instance. Constructor. def init, taking self. We want a list. Self dot L is an empty list. Fine. We also want two methods. Define add, taking self and some number n, and define mean, which will give us the mean. So, to add a number to the set of numbers that we are calculating is relatively straightforward. All we have to do is add it to the existing data structure, right? So, this one is a one-liner. Self.L.append n. So far, so good. Notice this doesn't return anything because it doesn't need to return anything. The effect of the method is a mutation of the state contained within the object itself. That is the end effect that you are looking for. You're not necessarily concerned with this thing returning anything. If it were to return anything, it would return a success or failure type result. You know, this operation succeeded or this operation didn't succeed. And my goodness, if this operation failed, we would have bigger problems than bigger problems than just deciding what the return value of that function should be. So, mean. How does one go about calculating the mean of a list? Yes?
Adding all the elements and dividing by the length.
Yes. Add all the elements and divide by the length. Return sum self.L divided by length self.L. So far so good. Let's test it to see if it works. Calc is mean calc. Calc.add 1, calc.add 10, calc.add 100, calc.add 1000. Then, insert calc dot print calc dot mean. So let's see how it works. The calculated average value is 277.75. Now, that may, you can, if you would like, you can verify that using your calculator. So here's a question. What happens if we ask for a mean before we've added any numbers to the calculator? Any predictions? Yes?
Zero division error?
It would be a zero division error. There you go. If you're dividing by the length of the data structure, if the data structure contains no elements, then you are in fact dividing by 0, which is an error. So, one way you might get around that, if length self.L is equal to 0, we return something other than a zero division error. For example, raise value error. give it a message, problem, empty calculator. Then, rather than simply failing out on a zero division error, which won't make any sense to anybody who's not seen the internal details of this object, we can return a more informative error statement which says, you are misusing it, and this is how. Any questions? Good. So I'd like to put a question to you. In this particular instance, we are using one piece of memory to store each number that is added to the dictionary, or added to the object. Is it necessary to do so? All we require to calculate the mean of a set of numbers is the sum and the length. These can be easily kept track of as elements are added to the dictionary, or to the calculator. So we can maybe come up with a bit more memory efficiency. Memory efficiency. So rather than storing things in a list, let's say self.sum is equal to 0, self.count is equal to 0. When we add something to the dictionary, we add that number to the running sum, and we add 1 to the count. Then, when we return the actual mean, all we have to do is divide the running sum by the running count. While this requires 2 additional lines of code, it eliminates the need for an entire data structure. It not only does this, it also improves the runtime efficiency of this algorithm. You may not realize it just to look at it, but to calculate the sum requires iterating through every element of the data structure. So, sum is big O(n), where n is the number of elements in the data structure. Now, adding each element individually to the data structure is also a big O(n) operation. But by keeping track of things as running totals rather than as a dictionary, or I keep saying dictionary, rather than as a list, we have taken the requesting of the mean from a big O(n) operation all the way down to a constant time operation. That is to say, it does not matter how large or how many numbers you have in this dictionary, finding the mean will always take the same amount of time. Constant time algorithms are the best time algorithms. But in order to gain these runtime efficiencies, we've had to give something up. What have we given up here?
Keeping the actual individual numbers.
Keeping the actual individual numbers. What's the advantage of keeping the individual numbers?
You can call back to them later.
You could come back to them later, yes. But for what purpose? You could delete numbers if you like to. Yeah, that's totally a thing that you might possibly want to be able to do. Another thing that you may wish to do, it is not uncommon with these type, like, think about what we would need in order to expand the functionality of this class to include other simple statistical functions, right? Right now, this thing only calculates mean. That's very simple, and using a class to do it is overkill, basically, you know. However, if you wanted to include something like median or mode, you would require the actual list of numbers, right? If you wanted to calculate standard deviation, you would need the actual list of numbers. If you wanted to calculate a rolling average, like the average of the last 10 entries or something like that, which you might not, rolling averages actually have a fair amount of application within engineering disciplines as kind of a noise suppression algorithm. But yeah, it's like, if you wanted to expand this in any way beyond the limits of just calculating the mean, it would take, it would take this implementation, not that implementation, to be able to expand it. However, if all you're concerned about is just calculating the mean, this is the more effective implementation. Does that make sense? Any questions about that? Yes?
Would it be less efficient to do the same thing as in, like, immediately process the numbers to whatever processes you want?
Yeah, well, I mean, even if we were to expand this out to the more statistical functions, it might still save us some time to keep a running sum and a running count and not have to recalculate them from the data set each time. And then we could keep the data itself in addition to that, and that might be a hybrid that combines the best of both approaches. But yeah, some things there are some things you can keep, running totals on, and some things you can't, right? Generally speaking, it's considered like a good trade to do things up front so that things are faster in the future. Like, for example, like an excellent example of that is searching algorithms, right? You remember the binary search algorithm that we did like a couple of weeks ago? Test. I think I might need a new battery. Are you running out of battery, sir? Let's see here. Do they have spare batteries? Is it working again? Yeah, okay. All right. I'm part Scottish, so I'll drain the battery completely. So, the binary search algorithm. Very fast and efficient algorithm because it's a logarithmic algorithm. It can search like 1 million entries in 10 or 20 steps, I forgot. I think like 14 steps. It can do 1 million entries, right? However, it requires the data set that you're searching to be sorted, right? Now, to sort data, like, it's some of the better sorting algorithms have run times in the n to the 4/3 and similar fractions. The basic sorting algorithms that you would learn, if you were to take the second year algorithms class, somewhere approximately n squared algorithms, right? So if you're using an n squared algorithm to achieve logarithmic time, it doesn't matter that you're using a logarithmic time algorithm because this is going to eat up all your runtime, right? But maintaining a sortedness property that already exists is just n. Because in order to maintain sortedness, well, actually, sorry, in order to maintain sortedness, that's actually log n, because to maintain sortedness, what you have to do is find the position in the data structure where that number would be placed to maintain it being sorted, right? Since we have, so that's a search algorithm. Since we have the binary search algorithm, which does that in logarithmic time, essentially all we need to do is perform binary search, find the place in the data structure where that element would need to be added to maintain the sortedness property, and then insert it at that point. Thus, we increase adding an element to the dictionary from a constant time algorithm to a logarithmic time algorithm, but we decrease the search operation from something in this order, or minimally minimally n, if you're just doing linear search, to a logarithmic time algorithm. So that's by front loading a little bit on the insert operation, you gain huge runtime rewards in the sort of general operation. And it also, it depends on and this kind of gets into more advanced algorithmic topics, but it also depends on how the system is being used, right? If, you have 1,000 search operations per add operation, then you can justify, some pretty heavy stuff inside of the add operation if you gain benefits inside of the search operation, right? But generally speaking, if you can get anything into logarithmic time, then, that's basically you're happy with your result. You don't have to push it much farther than this, Although it is cool to be able to get a logarithmic algorithm down to a constant time algorithm if you can manage it, but, for most purposes, if you can hit logarithmic time, then you're doing very well. Frankly, in most applications, if you can hit linear time, you're doing very well. But, the only thing that makes big data applications possible is getting runtimes down here. Because if you're, dealing with billions of data points, right? You're actually working, if you're working at the n squared level, then your actual, the number of statements you actually have to execute is on the order of a billion, right? Because it's squared. So that, that blows up quite substantially. But yeah, thank you for the question. Any other questions? Cool. So here's another question for you. Point of discussion. If we consider, I should rename this to be something else because now I've got a namespace conflict. There we go. So between mean calculator and mean calculator 2, from the perspective of someone who is using this class to calculate the mean, can the difference be discerned by them? Is it possible to know the difference between these two if all you're looking at is the inputs to the methods and the outputs from the methods? The answer is no. It is not possible to distinguish between the two of these. Now, obviously, you'd be able to distinguish between the two of them by profiling the program,
you know, determining the runtime, determining the memory usage, that sort of thing. Obviously, these two implementations will have different signatures and footprints in your operating system, but from the perspective of someone who's using this code to program, there's effectively no difference between the two of these. Classes provide data abstraction. In this case, what abstraction means is that it doesn't matter if we're using a list to store this information, or if we're using running sums to store this information, you don't need to know how it's being stored in order to use the object, or use the class. All you need to know is that this adds stuff to the data set, and that this returns the mean. It's, you know, a much more simple, compact thing to know. And, you know, if every programmer had to understand the operation of every function that they used, no one would be able to program. So, good. Let's see how many slides I've covered. Yep. Got that one, got that one. Got that one. Yes. Yes. So, okay. Any questions about any of that? Okay. So let's talk about protecting one's data. So we've been talking about how classes implement a data policy, right? And how it's a bad thing if your data policy has been violated. Python is a pretty loose language. It's entirely possible for someone to, like, you know, access your variables inside of your class using .syntax, mess with them, play with them, access them in a manner that you did not intend, right? There's a very, very important aspect of intentionality when it comes to the design of classes, right? You should try to prevent people from using things you write in manners you did not intend them to use it in. And, you know, it's like you want to try to force people to provide inputs at the points you have asked them to provide inputs, and ask for outputs at the points that you've decided to ask for outputs. It's like the global variables problem, right? Global variables are a way of getting around needing to use explicit arguments and return statements. And you can use them, but they have a tendency to turn your code into spaghetti code that nobody can understand. So, point of access is very important. But in order to do that, you have to be able to restrict people from being able to see the contents of a class. This is also known as information hiding. So and you know, there are lots of good reasons for this, you know. If you're a programmer and you're trying to use a class in a manner that it wasn't intended to be used, it is very likely that you have an internal impression in your brain of how that thing works. That's probably going to be different from that of the designer, right? So you are going to make assumptions about the code that are incorrect, which means you are going to make mistakes, which means you're going to bugger everything up. So, in object-oriented programming, we have a very, very important idea of the privacy of members. So, both attributes and functions can be private to a class. what it means to be private, well, I mean, you might be able to get that from the name, but it's like the employees only area of the McDonald's, you know? It's like, a class is kind of like a McDonald's restaurant. You have the front part, where everybody is, you know, eating and such, and you have the counter, which is the interface between the customer portion of the restaurant and the employee portion of the restaurant. And, you know, there are many functions that go on, you know, in the employee half that have little or nothing to do with you eating your hamburger, except that it, you know, is necessary for the maintenance of the restaurant. Like, for example, the manager's office. You don't need to know where the manager's office is or how many files there are in it, right? All you're interested in is the product of the kitchen and it being delivered to you over a counter. So, private members are kind of the same idea. It's a no-go zone for anybody who's not the class itself. So a private member can be used by the class where the private member has been defined, but not by anything exterior to the class. So it's like a local variable. It's a little bit like making it a local variable that can't be accessed outside of it, right? So the way that you do this in Python is by prefixing the name of a member by a double underscore, which, incidentally, is literally the worst way of doing this that I've ever seen in any programming language, but me complaining about Python should be routine by now. Literally, in most languages, you just declare the variable public or private, and then it just is. But in Python, because Python is Python, and Python is the worst, you literally have to go every single place that a variable has been used and put 2 underscore characters in front of it. Like, if I forget to put the 2 underscores here, that's a different variable now. I know, it doesn't make any sense, right? So the rule is, if you're going to make it private consistently. So, essentially, if I were to try to calc.s plus equals 10, you know, perform some kind of illegal modification, I get an error. Mean calc object has no attribute s, which is true. S with no underscores has not been defined, right? Oh wait, am I even using the right one? I'm not. Let me use the right one, and then we'll, you know. Yeah, in calc 2 does not have an attribute s. So, we don't have this thing existing. Now, interestingly, you can create it in Python just by assigning to it. Interesting. Oh, yeah. Have to, if self.count is equal to 0. There we go. So, you can't do this in most languages, but if you take any random attribute name and assign to it inside of, like using dot syntax, that actually adds that attribute with that name to the class, which is not what you want, but it's still distinct from the sum that is being used to calculate the mean. So the question is, okay, so what if I add the double underscores out here? It doesn't do anything, right? Notice that although, you know, I have supposedly reset the sum here, I haven't actually. right? Because the result is still the same. So it doesn't give you an error or anything, it just fails to perform the operation, which is, you know, again, I hate Python. I wish I was teaching you a better language, but, you know. So why do they even use Python then? Well, I think it's a conspiracy personally. I think that, like, I think about a decade ago, everybody mysteriously decided all at once that Python would be the language that was taught in first-year classes, and then everybody, you know, everybody therefore then learned Python, and now everybody's in grad school and everybody's using Python who's like not actually a computer scientist, and so it's created a market for learning Python because you know, it's like, you know, if you were doing a grad project, you know, basically, although Python is like hypothetically a requirement, you would actually be better off using most other languages. But, you know, everybody likes Python and everybody knows Python, and Python is considered easy to learn even though it's really not, because it's, you know, it's got a lot of arcane rules that it has because it's trying to cover up the fact that, you know, it's trying to cover up how things actually work, and it's much easier to actually learn how computers actually work than to learn all of the arcane little rules that Python has for getting around trying to hide how computers actually work from you. So, you know, not to mention it doesn't really have a functional type system despite its claims. Anyway. Yeah. So, I bet you didn't think that you were taking a Python class from a guy who hated Python so viscerally. Literally any other language is better than Python, but anyway. So far as it is. This is the mean calculator, but with the underscore characters included. This restricts access so that the only way that you can interact with the data contained inside of this mean calculator class is to use the methods as provided by the programmer. So, if the programmer did not provide you a way of removing an element from this, from the data set, then you don't have it. There's no way of getting around it or adding it yourself. Yeah? Any questions? Okay. So let's talk about the Marios. You see before you a diorama constructed from digital assets meant for the purposes of advertising a video game 2D platformer, well, 2.5D platformer, etc. The Mario is a software entity. Everything inside of a Mario game is an object in the object-oriented sense. So, what are some classes that we might have here? What do you guys think? Yes?
Balance class to keep track of the coins you collect.
Yeah, so a tracking class that keeps track of your lives, extra lives, and coins. Sure. Although I would say those might be attributes of the player character, rather than, since this is one of the ones that has simultaneous multiplayer where lives and coins are tracked separately for each character. So, to my mind, it would make sense to put those attributes in the character classes rather than have like a big game controller. Although you're going to have a game controller anyway to like run the background and load up the levels and that sort of thing. Anything else? Yes?
What
A class to keep track of movements. So what is movement? So those would be actions, right? Actions of a class. What class would they be attached to? Well, what's doing the moving and the jumping? The player character, right? The Mario himself. So Mario would have a method that would allow him to jump. He would have a method that would allow him to take damage from enemies. He would have a method which would allow him to collect power-ups, etc., etc., right? Mario would be a particular, Mario would be a class unto himself, inheriting from a general class for player characters, right? Each player character will have a set of common attributes. It makes sense to collect those up into a common class, have the particular character objects inherit from that general class. And player characters also share a set of properties with many other types of things that we see in the diorama before us, such as the enemy. In the same way that the player character has movement and actions that pertain to the physics engine, so too will the enemies. Goombas only move left and right, but they also fall off of cliffs. And when they fall off of cliffs, they follow parabolic arcs, which means that they are having gravitational force or simulated gravitational force applied to them, which means they are physics objects. In video game development land, we would call that a physics object or a rigid body. Well, a rigid body is a type of physics object that interacts with the physics system. You would also have colliders, which determine the boundaries of solid objects through which physics objects would not pass. So you can imagine, if you put on Matrix O-Vision and you look through the game and see the code, you would see little boxes around each one of these bricks that would designate them as colliders, or things that prevent things from moving through them. So the mushroom is a physics object because it moves, but it's a rigid body, right? It collides with the bottom, or the top edge of the box colliders on these bricks, thus preventing it from falling through the platform, right? Colliders would also be a class, but when you apply a collider to a physics object, that collider becomes, that's a composition relationship rather than an inheritance relationship, right? This has a collider. It is not itself a collider. It's more than just a collider, right? It has other properties. It has methods, like the method that allows it to be broken or turned into a solid block, because in the Marios, when you hit a block, it's somewhat random what happens to it. It might have a mushroom, it might have a coin, it might have an enemy, etc., etc. The level itself would be a class. The objects in the level would be classes. These hills in the background, each one would be a three-dimensional model, which would be an object inside of the game engine. The difference between a Goomba and a Paragoomba is only a pair of wings and some movement physics, right? So, Paragoomba would inherit from Goomba and also be composed with an object representing the wings, which would be placed so and so according to the definition of the object, and it would have a few additional movement methods, right? Does that make sense? So this is all of the examples of classes which we have talked about thus far have been relatively, simple. But it really is the case that if you take these definitions and you use this as a system for organizing data, you can come up with some pretty complicated stuff. And, Mario as he currently exists is a lot more complicated than as he existed on the Nintendo Entertainment System. Yeah. So, yes, possible class hierarchies. We might have characters which are either playable or non-playable. Non-playable would include the Goombas and the Koopa Troopas. A general class of things called widgets, which are generally things in the level which you can interact with. Things such as bricks and question mark blocks and pipes, which may or may not lead to somewhere and exist as a warp point in the level. And of course the level itself. This is of course not by any means an exhaustive description of the classes that can be contained in such a software entity. Has anybody, have you guys actually played Mario at any point in your lives? Most of you? Okay. All but one. Okay. Cool. Good. So if we were to talk about the types of properties that we would apply to these classes, considering playable characters, we might have properties such as name of the character, or some kind of identification tag. Is the character in the big state, Big Mario versus, it's actually technically called Super Mario versus regular Mario. Do we have a feather, or do we have the propeller cap, or do we have any of the particular power-ups? How many coins do we have? What is our x and y coordinate in game space? What is our x and y velocity in game space? What are our x and y accelerations in game space? All of those variables that you would need to keep track of movement inside of a game environment. You would have methods such as, well, that's not how you would do that inside of game world. The way that movement works, generally speaking, is when you press a directional button, a certain amount of there's like an acceleration curve which is applied, So you don't ever modify position directly because that's kind of like spitting in the face of the physics engine. Not to mention the physics engine will be designed to handle, do calculations based on objects which are accelerating towards colliders, not, basically, if you do this with position rather than with acceleration, if you have a collider and an object, basically you're just popping it, in different positions, right? You're just sort of positionally moving it to different, it's like stop frame animation. And it does work in animation-wise because, if you do that fast enough, then it looks like you're animating. But the way that the physics engine will generally work is that you also have, at each point in time, velocity relative to the collider, and the physics engine will calculate at each point in time whether at any point between this frame and the next frame you will have passed through this object based on current velocity. Velocity generally doesn't change between frames, right? Well, it might, it depends on how complicated the physics engine is, but generally it's not necessary because the, the velocity is being updated sufficiently frequently by the frame rate of the game itself that it doesn't necessarily need to be like non-linearly updated between frames. But anyway, so yeah. Attributes of, for example, a question mark block. Question mark blocks have a x and y position in space. They have a content, contents might link to some other game object such as mushroom or fire flower. Used or unused state. Smash or activate, question block. And a very important one, draw on screen. If your player cannot see the object, then how do they interact with it? That being said, there would be, in a game such as this, a large number of abstract classes as well. For example, the save data for a game like this would be stored inside of a class as well, and that class can be serialized and stored as a file inside of the permanent memory systems of the computer, right? Which is something that we're going to talk about now. Are there any questions? Are there any more questions about classes before we move on to our next topic? Okay. Good. So, recall the different types of memory. We have random access memory, roughly equivalent to your RAM chips inside of your computer, which is the working memory of the programs currently executing on your computer. In addition to this, we have read-only memory, ROM. This is your hard disk, whether it be a solid-state drive or a magnetic drive, doesn't matter. What it does is it stores data long-term. The storage of data inside of a computer is organized into a file system. And the various files in your file system are what you view when you open up Windows Explorer or any, file folder viewing application. Incidentally, folders are also files. Just putting it out there. So when we interact when you print data, what you are in fact doing is you are interacting with a file that is maintained by the operating system itself. Some files are needed and used by the operating system and are updated frequently. When you're interacting with a command line interface, printing data to it and taking input from it, you are interacting with files known as standard input and standard output. Standard output is a file into which things that are printed are placed. The operating system periodically pulls what the data that's inside of it, and outputs it to whatever the active display is, should the active display request it. This is what the print method, or the print function, actually does. It is writing string data to a file. The input file reads data from, or the input function reads data from the standard input file. The way that standard input works, when you press keys on your keyboard, keystrokes are logged and stored inside of standard input. when standard input is when the data in standard input is requested, it ends up as the return result of the input function. So that's how you acquire keystrokes into your program. Good. So, printing to a screen and reading from the user are modeled by special files called standard input and standard output. In command line scripts, we can redirect standard input and output to files. While this is outside of the scope of this course, it is not outside of the scope of Computer Science 1X C3, because this is kind of touching on more Linuxy type stuff. Generally speaking, Windows is designed so that you don't have to worry about this type of thing, because Windows, well, I won't get into it. Good. So, what is a file? A file is a collection of bits which are stored on your hard drive, which are accessed via the file hierarchy, which is a system for organizing the management and access of files. Right? Files are just collections of bits. It's interesting because most people think of file extensions as most people think of files as in the categories of their file extension. You don't think of files in general. You think about Word documents, and you think about Excel spreadsheets, and you think about web page HTML files, and you think about PDFs, right? The truth is, there's nothing specific about a file that makes it, a Word document other than the arrangement of bits inside of the file, right? This is why programs other than Microsoft Word can read Microsoft Word files, right? Any program can open any file, as an operation. However, most programs are designed to reject any files that do not match certain file formats, right? So we're going to talk about files, and we are also going to talk about file formats, some of the simpler ones, in the course of this lecture. It's entirely possible for you to make up your own file extensions, right? Literally all you have to do is rename the file with a file extension that you choose, and bam, there you go, So, if I were to open up thingy samples, if I were to get it, or to edit, 1MD3 dot, this is a file extension. Perfectly possible, right? Now, obviously, that's not a file extension that any program would recognize as, denoting valid a valid, contents. But you can, go ahead and type stuff in it, and everything's fine, right? Save that up, close it down, view the file, and it stores the data, right? Now, this program that I've been using, which you've seen me use many times, this is what's called a plain text editor. A plain text editor basically is agnostic as to file extension. You can open any type of file in a text editor. It will decode that file as ASCII, and you can modify it and save it and do whatever you want. Not all files are ASCII files. Some files, such as image files, are what's called binary encoded. Let's see here. Need to find an image file. Probably find one in the slides. Oh, there's one. So, this is a .png file, right? Portable network graphics, or portable network graphic. So, I can open this file using my text editor. However, the contents don't show up very usefully, shall we say. That's because .png files are not ASCII encoded, right? They're not encoded as strings. They're encoded as binary data. So something more like integers or floating point numbers. When you try to view that, when you try to decode that as an ASCII file, you get all of this garbage, right? This isn't actually garbage. This does represent the image, right? It's just, it doesn't make any sense in ASCII. Whereas, if you take that file and you decode it using something else, like a image viewer, and all an image viewer is a program which knows how to just decode most of the image formats and display them, then you see the graphic, right? Good. So this is roughly speaking what a file is. Question?
Was the ASCII one in hexadecimal?
You can think of it as being in hexadecimal, although it wasn't being displayed in hexadecimal. Yeah, these guys here, these will be hexadecimal codes. You can always tell it's hexadecimal because there won't be any character higher than F, right? The max it'll ever get to is F. But yeah, essentially what it's doing is these are stand-ins for Unicode characters that don't have Unicode definitions and stuff like that. So at least in this font, right? That's why you have interesting symbols like this one and this one, which are not in the, I said they were being decoded as ASCII, but they're actually being decoded in Unicode. Although it might be UTF-8, now that I think about it, since these appear to be in 8-bit chunks. But at any rate, yeah, it's taking the entire file, breaking it down in terms of these, hexadecimal codes, and then trying to display those as Unicode characters, but that doesn't work most of the time, right? Because this, the font that's being used by Gedit simply lacks most of these characters. Make sense? Any other questions? Okay. So, the question then becomes, given that files are where most of the useful data in the world is being stored, how is it that we might go about writing a Python program which accesses data inside of files, and how do we go about using that data once it's been accessed? Well, there's a procedure. Number one, the file must be opened by your program. in order to obtain what's called a file handle. A file handle is an object in Python which contains all of the information relevant to the reading of that file. In some other languages, this is called a file stream. So you don't normally, there's a difference between opening the file and reading the file, right? Opening the file is the same operation regardless as to whether you're reading from or writing to the file. Opening is the same, it's just, you open in a different mode. So once you have this symbolic link to the file, you can then perform operations over it. Things like reading lines out of the file, writing lines into the file, and other, assorted operations. Mostly just reading and writing, though. Once you have finished whatever operations you wish to perform on the file, you must close the file. This has to do with operating system problems. So, one of the things that you have to prevent if you are an operating system is you have to prevent multiple people accessing a file at once. That is a big no-go. So let's imagine that we had, a file, right? And we had program 1 represented by smiley face, and program 2 also represented by smiley face, right? Let's say, just for the sake of interest, that program 1 opens file x.x, and person 2 opens file x.x as well. Let's imagine they both open the file in write mode, right? If this person, right, if this program adds the line A, B, C, and this person adds the line D, E, F, one of two things happen, right? Either you get A, B, C, D, E, F, or you get D, E, F, A, B, C, depending on A, whether the order in which these commands were sent, and B, depending on whether they're using append mode rather than overwrite mode. If one of them is using overwrite mode and the other is using append mode, then, say this guy is using overwrite and this person's using append, then the results in the file will just be A, B, C, and this operation will look like it's succeeded, but will have in fact failed because this guy will have overwritten it, and the same is true in reverse. If this is an overwrite operation and this is an append operation, then def will overwrite ABC, or DEF will overwrite ABC. The point I'm trying to make is that this is a bloody mess, right? You don't want people simultaneously accessing files. It just doesn't work very well. Now, all of you crazy young people will probably be saying to me, but Mr., what about all of the Googles? What about all of the Google documents? What about all of the Google spreadsheets? These have multiple people editing one file, and they seem to manage it. And it's like, okay, first of all, Google is not an operating system, right? Google is like its own thing, It's a product. Think of it as a product. Number two, the way that works is you're not modifying the file directly. What you're doing is you're communicating with a third-party interface, which is managing everybody's interaction with the file. You just can't see it, right? So how a Google document would work is you'd have your you know, you'd have your 4 people working on the project, only 2 of whom are useful. You'd have all of these people communicating with a server sending characters to be written into the document counts as a communication packet with the server, right? And then the server takes all of those and modifies the document with it. And that business where you can see other people's cursors is also just, you know, anytime you press left or right inside the spreadsheet, what you're doing is you're sending a command to the server, move my cursor left or right, right? You're not like, you know, you're going through a third-party interface, and this third-party interface is not doing everything all at the same time, right? It's doing things, you know, it's faking parallelism the same way that computers always fake parallelism by doing things sufficiently quickly that it looks like everything's happening at the same time, but it's not, right? It's managing requests. It's managing packet requests from multiple people all at once and displaying the results to all of you as well. So it's not like you've all got the file open in the sense of a base operating system, right? That's not how it works. It works much more similarly to a database model, right? So there you go. More information that you never asked for. So, this is complicated network stuff. This is nice and easy operating system stuff. So, that's what we're going to be talking about. So in review, you open the file, you perform whatever data that you need to, or you perform whatever operations you need to, then at the end you close the file. So, the purpose of closing the file is sending a message to the operating system that you're done with the file so somebody else can have it, right? So whoever gets there first gets access to the file until they close it, right? So it's like this guy, it's like, I want access to this file, puts a lock on it. Any requests to open the file by this process will be rebuffed. They will fail. You'll get an error that says something like, file already in use. Until such time as process 1 closes the file. It releases the lock on the file, and that file now may be opened by requests from other processes, and still subject to the lock. However, this other process, it depends on how the operating system chooses to handle it, but you might have to keep asking until you succeed, basically. Does that make sense? So that's the importance of the close operation. It releases control of the file back to the operating system. Yeah? Good? So, opening a file for reading is relatively simple. Let me see here. Now that'll do. Get it, topic 9.py. So, put you here, put you over here. Oh, boink, there we go. All right, so file handle is an object and is the return result of the open function. So, we open some file name expressed as a string in a mode also expressed as a string. In this case, we want read mode, so we specify R. So let's pick a file that we want to open. Let's say topic4.py. Topic for.py. Then, so we have the file handle open. The next thing that we want to do in this example is read the contents of the file into a string in Python. So, string is equal to filehandle.read. Now there are a bunch of different ones. Read does the entire file. Read line only reads a single line, as you might expect from the title. So, good. Then we can do whatever we want with the string, such as print it, and of course, fh.close at the end. So, let's run this bad boy, see what we get. And there we go. There you have it. The contents of topic4.py expressed as a string in Python. Now, because this is a string in Python, we can do all kinds of things to it. For example, let's say you wanted to remove any blank lines, right? Fairly typical. So if we take a look, like a blank line will normally, so this is what a blank line will look like in terms of ASCII code, right? You'll have, some characters, a new line character, a sequence of characters that's either tabs or spaces, and then another new line character, and then it'll continue on, right? That's the pattern for a blank line. So, let's see if we can identify that. For a character in, or C in S, let's make a Boolean variable skipping so that we can keep stuff out while we're not skipping and throw stuff out while we're skipping, right? So skipping equals false. S2 is equal to an empty string. Well, actually, I think it might be easier to just look ahead. I've changed my mind. Okay, let's do it differently. So, for C in S, actually, I think this would be easier with a while loop. I'm going to do, so, I is equal to 0, while I is less than the length of S, and we're going to do this. So, if if S at I is equal to new line character, then we want to move forward through the string, checking to see if the only thing between this new line character and the next new line character is white space characters. So we'll say j is equal to I plus 1, while S at j is not equal to new line, or and s at j is still less than the length of s, because we don't want it to exceed bounds. If s at j is equal to a blank space, or s at j is equal to the tab character, then we continue on with the test. Otherwise, we break from the loop. Now, it'll be useful to have a flag here that indicates whether or not this loop was broken prematurely. So, flag is false. If it's broken prematurely, flag will be true. Then at the end of this, we can test the flag to see whether or not this was a valid blank line. So if flag equals false, then the blank line was valid. So by the end of this, basically we want to skip everything between these, like between from I plus 1 all the way to what eventually will be j. You want to take that and throw it away, right? So s is equal to s from the beginning to I plus 1, concatenated with s from from j plus 1 to the end. Assuming that there isn't a blank line at the end, I guess, but we can debug it, it'll be fun. So there we go. And of course we can't forget to increment I at the end of the loop, nor can we forget to increment j at the end of this loop. Further to that, this is kind of a dumb construction, so there we go. All right, maybe this will work. Don't really need this anymore. So let's see if this works. I've got a loop. Oh, there we go. See? Common class of error. There we go. Comparison not supported on instances of string and int. Oh, yeah, well. Because I want j, not s at j. Index error, string out of range. Yes. And I is less than length of s minus 1. That just stops at one thing before the end. So, there we go. Ha! Boom! That worked. So, for example, if I open up topic4.py, this is a blank line, right? It contains a tab character. This is a blank line that contains no characters. And if I were to add a blank line that contained space characters, that should be removed as well. Yep, it's removed. So there you go. That actually worked. And you might be saying to yourself, big deal. I could have done that in 3 seconds with my friggin' keyboard, man. And it's like, oh yeah? Could you have done that in 3 seconds? To 100 million files? Not likely, my friend, not likely. By automating things rather than doing them yourself, you do them much faster. It's normally worth the investment to write a quick script to modify a file rather than doing it yourself. If it's some operation like removing blank lines or removing comments or anything of that nature. Yes. Any questions? Cool. So, we've seen how to open a file. We've seen how to read from a file. We've seen how to process what we have read from a file. Now let's see how to write something back into the file system. So, in order to write something into the file system, we open a new file handle. It can be named, it's okay to use the same name that you used before, so long as you don't have multiple files open simultaneously with the same name, because, obviously. So, file handle.open. Pick a name for it. topic4.py.out. Oh, yes, folks. That's right. Files can have multiple file extensions. There's nothing magical about the period character. You can have as many as you like, assuming you're in Linux and not the inferior house feature-based operating system. We open it in write mode. fh.write string fh.close. I think I got that right. So, this executes with no problems, but let's see if the file was actually created. This ls is a Linux command which lists the contents of the currently open directory. You'll notice we now have not only topic4.py, but topic4.py.out. Our file has been created. Next step, check to see if the contents are correct. You can use a couple of different commands for that in Linux, but cat works pretty well. Stands for catalog, I think. So you'll see the contents of topic4.py.out are precisely and exactly that which is output by the string, output by printing the string from Python. So we have exactly and precisely transferred the contents of random access memory as stored by your Python program into the file system. Any questions about any of that? The commands aren't too bad, right? Like, this is pretty simple in terms of commands to do something, right? It's mostly like, most of the difficulty in this is the actual processing of the inputs, or processing of the files itself, right? You know, that being said, you know, you do have to be familiar with the procedure, and there are a couple of pitfalls, but yeah. Any questions? Good. Everybody's going to get perfect on the exam then? I'm so looking forward to tomorrow. Today's the last day of the mandatory mask mandate, eh? On campus. You guys get the email? Yeah. I'm looking forward to oxygen again. Yeah. I mean, like, what kind of cruelty is it to be forced to breathe your own carbon dioxide, like, endlessly, you know? Terrible. Anyway, so, see how much of the slides I've covered. So, going back to reading for a moment, in addition to reading the entire file contents into memory as a string, you also have the option of reading the individual lines of a file into memory one at a time. If, for example, rather than storing and dumping everything as one big string, you would prefer, you know, having a list where each line in the file is a different entry in the list, it would be reasonably easy to read those lines individually from the file handle and then append those lines to a running total list that you had, that you instantiated before the loop. Make sense? Good. So I've shown you the manual way of closing files. You should be aware that the close operation works and exists. But in Python, there is a shortcut that is provided which allows you to not have to remember to close the file when you're finished with it. We haven't really discussed the with clause yet, but you know, you can think of it as a variable binding. So what we're doing with open myfile.txt in read mode as file handle s equals fh.read. What this line does is it creates a variable scoped within the block of indentation following the with statement. When that file handle is no longer in scope, Python knows to close the file handle using fh.close. It does it for you. So this is a slightly more it's like how for loops are like slightly less prone to error than while loops because they do a few things for you. And this is a similar instance with statements. So we can take our previous code and refactor it so that it uses this new method. So rather than saying fh.open and then closing it at the end, what we can do instead is say with open this as fh. We perform the read operation, and then we can get rid of that close statement. So while fh is local to the with block, the string s is not. So all of these operations that we're performing on s will now be happening after the file has been closed, which is not a big problem in this case because we are reading it all up front. However, if you were going through it line by line, you would need to put whatever code is represents the actual information processing inside of this indentation block. Make sense? Good. In the same way, open that as fh. There we go, and we can run it just to prove that it works. Boom. Make sense? So, here's a code example if you would prefer to read line by line. Line equals fh.readLine. While line is not equal to blank, read the line. And then at the end of the loop, you refresh line by reading the next line from the file handle. This is an example, another example of a while loop that does not necessarily have a direct interpretation as a for loop, unless the for loop has been specially designed for this type of situation, which, as it turns out, it has for reading files, because this is a fairly common operation. But this is like we're not going by index through the elements of a data structure with this loop, right? So for loop is not exactly equivalent. At any rate, so this empty string here, a blank line will at minimum contain a new line character. But if you've read a line and it contains actually nothing, you have reached the end of the file. So this is, in Python, the test for having reached the end of the file. Make sense? So, equivalently, the for loop can also be used to read each line from the file. However, you'll notice we're not even using the readLine function inside of this program, at least not on the surface level. In the same way that iterable has a definition for dictionaries and lists and sets, iterable has a definition for file handles. The definition of it for file handles is iterable reads through each line in a file in sequence until it reaches the end of the file. So, when you for loop like this, each line is a new line in the file. Each time the loop iterates. This line will include the end of line character, new line character. You can remove that using rstrip or, any other method that you might want. From 0 to -1, I think, would work just as well. Let me actually test that in case I'm speaking nonsense. Let's see here. Python 3 hello world from beginning to -1. Yep, that does. That removes the last character of using list slicing. Good. So, when opening files, particularly opening files in read mode, if the file that you're trying to read doesn't exist, you will get a file not found error. This does not happen in write mode. If you open a file that does not exist in write mode, it assumes that you want to create that file, and then it creates it for you, and puts anything you want in the file. However, this is very similar to the variable reading problem. You can't read from a variable before it's been written to. In the same way, you can't read a file before it's been created. It's just a causality problem. Make sense? So, a common sort of thing that I ask on, tests and exams is, because in case you were wondering, the exam will certainly contain a question on classes, and the exam will certainly contain a question on file I/O. Normally with the exam, I throw something in that's worth a couple of marks. That's like, if the file that you're requesting to open doesn't open for some reason, correct the name of the file to add the file extension you're looking for or something, and then retry it. And if that still doesn't work, then you can return the file not found error. Just that sort of thing is that type of small manipulation is something that I ask a lot. So just so you know. Yep. So we've already seen how to write to a file. So the interesting thing about the write file, though, if you take a look at the list of functions presented here, you may notice the absence of an analog to read line. The fact is that write already acts in this manner. Every time you write to a file, you can write to a file multiple times. Each time you write it to a file, the new thing that you write will be added to the end of the file. So it's, if the things that you are writing are all single lines of a file, then it is, in effect, write line. Otherwise, it's just write. Right? Incidentally, the print function itself has an option where you can specify the file handle as the file that print is printing to, which is kind of interesting. That operates a bit more like write line. So, if you're interested in taking advantage of, the separator or the end character quantities of the print function, or you're interested in taking advantage of the, automatic string conversion that's implicit in the print function, then, print is a perfectly valid option as well. The thing to keep in mind about the write method is that it does not, to my knowledge, contain implicit string conversion. Although I could be wrong about that, but it expects a string. This does not. So if you don't have a string, probably print is what you want. Make sense? Question?
What's the difference between write mode and append mode?
Sorry, write one and...
Append mode.
Oh, good question. So, in write mode, that's overwrite. So, if you have a file, right? If you have a file, and that file has some contents, if the computer opens it in write mode, it erases the existing contents of the file, and then adds whatever contents you add. If you're in append mode, it's the same thing as with lists. In append mode, you add whatever is new to the end of the existing file without overwriting the existing data. Make sense? Cool. Any other questions? Cool. This stuff isn't too bad, right? So, here's an example, writing stuff to a file using print statements. So, you can also access standard output directly using system functions. You don't have to go through print. one thing that I, like, there was a question that I asked once on a test that asked the students to actually write some documentation for one of their functions. And in order to make that play nice with the autograder, right, because, like, you know, in theory, the grading of that, like, I want to try to avoid having the TAs have to do that manually if possible, because then they have more time to spend with you guys. Basically, using functions not dissimilar to this, I called the help function on the functions that the students had written, captured the standard output, because the help function writes whatever the docstring is to standard output, right? So I captured standard output and then did like a basic keyword search to make sure that like any of some very basic descriptive words were used, which should certainly be present in, you know, in any documentation of a function. And people got grades for that. Although I think most people skipped the documentation part. So, good. So let's talk about the internet in the last 10 minutes of class. So, what is the internet? Anybody have any clue what the internet is? I think most people have no clue what the internet is. Even people who know technically what the internet is, they have no idea what the internet is. Anybody have any ideas? Yes? It's a bunch of data. Well, I mean, yes, but, you know, that's not a very refined description, shall we say. What's the internet? Okay. The internet is a massive distributed file system where the files of this great global computer are accessed via communication packets and addressing. But, fundamentally, when you access a web page, what you are actually doing, is you are performing a request for remote data from another computer, usually a server. So, inside of the file system of the server, a file will be contained, right? Say it's an HTML file, or it's like, you know, it's a movie file that you want to watch, you know, or it's a PDF file that you want to read, any type of file. Your computer sends packet requests to the remote server saying, I would like to read the contents of this file, please. And that remote server is like, okay, here you go. Or it says, nope, can't do that right now, sorry. Too many requests. Get to the back of the queue. So that's very roughly speaking how the internet works. Like, it's interesting, right? Because like most people think of browsers as being the internet, but all they're really doing is rendering HTML files or, you know, associated files like CSS files, and, you know, there are a lot of different file formats that that are used on the internet these days, but, you know, the basic one and the one that started it all is HTML, which is Hypertext Markup Language. So a browser is just a renderer for these files, right? When you load a web page, you're requesting a file be downloaded to your local computer and then rendered the same way that an image viewer renders an image, right? Or, you know, the same way that my text editor renders things in ASCII. So, given that all you're doing when you're using the internet is performing remote data access, it is possible to write Python programs which access the internet, so long as you have the correct address and, an available access port. So, in this particular example, we will use the URL lib module, or library, to access internet data, or see an example of how internet data might be accessed. So, first, of course, we have to import URL library.request. Further, we need a valid URL address. Notice, in this particular case, the .txt extension, meaning that we're accessing a text file, plain text file. Basically, the reason that most of the time when you enter a URL, you don't specify a file name, is when you enter a website address like www.facebook.com, that will redirect your request to a file called index.html that's contained in that folder. But anyway, so you capture the response packet object, which is the return result of urllib.request.url open URL. You then read that, you perform the read operation over that response, store it in some string, and Bob's your uncle. You have read string data off of the internet. Now, whether that data is interesting or useful depends on many things. But, yes. But here's the thing, right? The internet is a big place. Not all of the data that is on the internet is encoded in ASCII or UTF-8. There are competing character formats. So, when you access information off of the internet, it is received by Python as binary data. Now, that binary data, if you choose to interpret it as ASCII, will most likely show up as ASCII or UTF-8 or UTF-16, but this is not necessarily guaranteed to be the case. If your if the website you're trying to access is using some other form of character encoding, then interpreting it as UTF-16 will result in the same type of garbling that trying to open a PNG file using and interpreting that as UTF-8 would produce. So, to decode a packet according to a particular character format, the first thing that you have to do is get the content character set from the response packet itself. One of the very clever things about the Internet Protocol packets is that they contain within themselves information relevant to the decoding of the information that they are providing. So, a certain amount of information is transferred by default when you have a packet that's sent. Part of that is what the encoding of that packet is. So you can read that using this line of code, then response.read.decode according to that character set, and then you'll be able to print it. Make sense? So, yeah. Similarly to opening a file handle, response packets can be read line by using for loops, and they can be decoded individually. If that's what you're going for. Further, In the same way that a missing file, trying to access a file that doesn't exist, results in a file not found error, trying to access a URL that doesn't exist results in an HTTP error. So you can check for that. Any questions about any of that? Well, we've only got 2 minutes left in class, which isn't really enough time to start into the next topic, so yeah, I think that's it. Question?
Will we have a tutorial on files and internet data?
Yes, you'll have a tutorial on files, for sure. To be honest, the internet data thing is kind of like lightly covered, you know? We're more concerned, like if you're gonna spend time focusing your studying here, I would focus it here and there. So yeah. Any other questions? All right. See you next week.